Hi, my name is Fraser and welcome to Graphic Card Repairs. Today we have this Gainward Phoenix RTX 3090 and the user reported that this card is not getting detected. So let's check the resistance and see what exactly is going on. Maybe some of the voltages are missing. So once we check the resistance, we'll know what exactly is happening. So let's measure the resistance on the PCIe first. Let's start with the 12 volt PCIe. And we have the capacitors charging nicely. Let's check the 3.3 volts. That's good. We don't have a short there. The 8 pin, no short. And we don't have a short on the other 8 pin as well. Okay, so let's open this card up and we'll continue from there. Okay, so the cooler has been removed. Let's check if we can see anything obvious. I can't see anything, anything which is out of place here. Uh, Nothing at the back as well. Let's take a look under the microscope. Let's zoom in a bit. Okay, it's just the top side that I see there's some moisture there and some dirt that's accumulated because of the moisture. But at the bottom I don't see anything. It looks nice and clean. So I assume this card was used for mining before, because normally mining cards are used in rooms which are air conditioned, and because of that, due to condensation, you find moisture on the top of the card. So I think this is one of those cards. So you can see that corrosion on the pins there. This is the top side. But otherwise, this card is pretty clean. I don't see anything that looks faulty or corroded. Nothing of that sort. So far, everything looks okay to me. Okay. So let's check the resistance on all the pins, all the inductors. So starting with the 8 pin again, and the capacitors are charging nicely. Okay, yeah, this side is fine as well. Let's take a look at the 5 volt. And 5 volt is good. The auxiliary 12 volt. Okay, something is not looking okay, but we'll come back to it. 1.8 is good, and PEX is good. Okay, so the resistance are fine. Let's take a look at the back. Let's check memory. Memory is good as well. We have another 12 volt inductor here. Okay. Okay, there is no short here. So maybe I'm not getting a proper contact. Okay. Let's take a look under the microscope. Let's see if there's anything that's... Why are we not getting a proper reading here? Everything looks to be fine, but yeah, everything is good. Nothing visible. Okay, the good thing is we don't have a short there, but we'll come back to it if we have a problem. Okay, so time to connect the voltage. Let's see if we can measure the voltage. Let's check what the amps rating is, and we have about 2.3 amps. So 2.3 amps means most of the core is working and most of the voltages are working. Let's see what we are missing out. Let's check the 12 volts, 8 pin. We have about 10 amps or 10 volts, sorry. And now we don't. Okay, that's strange. So we are losing out on the 12 volt. Is there something wrong with my connector there? Okay, let's check again. No. So something is not right here. My connector looks to be good, but the 12 volts, it just drops down. Okay, now we have the 12 volts. So you might be wondering it's only 10, and that's because the amps is only 3 amps that I'm passing through. So it tries to draw more than 3 amps. That's why it drops the voltage down to 10. 5 volts, we do have 5 volts. Let's take a look at 1.8. And we do have 1.8. Let's take a look at PEX. Okay, we are missing PEX. Let's check again. We are missing PEX. So let's take a look at memory and core. Let's take a look at both. We do have core. What about memory? So the core is okay. Let's check memory. Oh. Let me connect this bit. Let's check again. We do have memory. Okay, so the only voltage that's missing is PEX. Yeah, that's the one. Okay, so let's put in some standoffs and probably we'll get a flat surface. Let's hope we get a better angle at testing things. I don't think that's going to work. Let's find out. Okay, so our standoffs are in. Let's zoom in on the PEX. Okay, so let me switch the camera so you can see what I'm doing. Okay, let's start measuring the resistance first, or voltage, and we don't get PEX. I don't see anything burnt or something that would show us a sign that something is faulty. There's something around, so it's something has to be in this area here. So in this case, the PEX gets activated after the core, and our core is working, and it's just that we are missing out on the PEX. So I'll just probe around a bit and I'll get back to you with my findings. Okay, so let me show this to you. So in this area, so all our voltages that are required are available, but this is the 12 volt line, and I want to show you something here. So if I measure the 12 volt line here, and you can see that there is a short. It's a 0-ohm short. This is also a 12 volt line, and it's connected to ground. So there's something wrong either with the chip here, or there is a capacitor or something somewhere on this line that is shorted to ground. Okay, so even though we do see a short here on the 12 volt line to ground, we don't see anything on the 8 pin. That's the strangest part. And this line connects through a resistor, that's this resistor here, and from this resistor it connects to this one. This is the 0-ohm resistor, and from there it connects to this shunt resistor here. So we have something in between that is shorted, but we are not getting a short on the 8 pin. So if I take a look at this side of the resistor, and we don't have a short, but if we take a look at this side of the resistor, we do have a short. So our resistor is blown, so it looks like our resistor has saved our card. So let's get this resistor off. So let's take a look what it reads, and it shows in mega ohms. It's supposed to be a 0-ohm resistor, 3.7 mega ohms. Okay, so let's get this thing off and we'll continue from there. Okay, so I have connected a jumper. Let's inject some voltage here and let's find out what glows. So I'm going to inject 1 volt and 4.5 amps. Let's inject now. Okay, there you go. So there's something glowing here. It's very faint, but it's obvious. I can see that. I don't know if you can see it on the camera. I think now you should be able to see. There you go. You see that? That's our short. Okay, so there are 2 capacitors connected there. So it's one of them. Let's take a closer look. Let me switch. Okay, so one of those 2 capacitors is shorted. So I feel that it's the top one, but let's put in some isopropyl alcohol and let's see which one evaporates the alcohol first. There you go. So we have some alcohol there. There you can see the alcohol. I think I put in too much. Let me just wet the top of the capacitor. So you can see the bottom one, it still holds the isopropyl long enough, but the top one evaporates it much faster. So I think it's the top one that's faulty. So let me get this thing off. And let's see if our short goes away after we remove that capacitor. So let's get this thing off now. Okay. Let's measure the resistance and see if our short is gone. Okay, let's measure this side first. Okay, so this side is ground. Let's check the other side. And we have an open line. So which is good. So that means our short is gone. Let's check this resistor. This side is ground and an open line on this side. Fine. Okay. So we might have a fix. Let's check on the resistor here. Is our short really gone? Let's check here. And we don't have a short. We still show open line, so which is a good sign. Which is good. Let's check this side of the resistor and we have capacitors charging and an open line. So that's because there is no resistor connecting both the ends. Let's take a look at PEX, the area where 12 volt connects, and we have an open line. So our short is gone. So it was the capacitor that was shorted and that had caused the card not to boot. So let's get this wire off. Okay, I don't think that's a little bit too big. Let me find another register. Okay, I think this one is a little bit too thick. This one is slightly bigger. I don't have anything smaller than this, but I think this should do. We'll try and make it fit. I think this should do. Okay, so this is the smallest size that I have. Not that I do have 04 or 02s, but that's too small. Okay, so I don't have space on the other side, so I'm just trying to, fit in a larger resistor in a smaller space. Okay, I think that should do the trick. I have solder melted on both the ends. I think it's connected. Let's check on the PEX and see if it makes contact. Yes, it does. So we can see the capacitors charging now. Okay, so that's a good sign. So we have the flow of voltage, the 12 volts connected to the PEX. So we should have our PEX. That's in theory, but let's check. Yes, we do. Okay, so we have a PEX. Let's put this card on the bench and see if this card gets detected and if we get any picture. Okay, so the card is on the bench. Let's put this thing up and check if we get any picture. First, we'll check if the card gets detected. The bench should restart if it gets detected. Yes, looks like it got detected. It's booting again. Let's see if we have a picture. And we do. Lovely. Okay, so let's take this card out from here, clean it a bit and assemble the cooler and put it back. Okay, so the card has been assembled. Let's put it back on our bench and boot it up. Let's see if we get a picture again. Okay, the fans are spinning. Let's see if we get a picture, and we do. Okay, so let's boot to Windows, load the drivers and run a couple of tests. Okay, so FurMark is running, and the clock speed and the memory clocks are all looking good. The power draw is looking good, and everything looks smooth for now. The graph is curving nicely and it's not a straight line up, so which is a good sign. So temps are holding pretty well. The core temperature and the hotspot is within the delta, so which is nice. So everything is running as expected. Okay, so that's it for this video. I hope you like it. If you do like it, please hit the like button, and don't forget to comment in the comment section and share your thoughts. What do you think about this repair? And thank you for watching. You have a good day. Bye for now. Cheers.